All right, you guys are going to be working on slope fields today. All right, a slope field is sometimes called a direction field. Okay, and what it is that it's an equation, it's like a graph to describe a differential equation. So if I gave you guys dy dx equals, I don't know, something like 2x. I have a feeling it doesn't matter. Okay, so what this is, it tells us that our slopes at any point are just twice the x value. So we can actually draw what that looks like, okay, by whatever the x value is. Plug in your x value, figure out what your slopes are. So if I plug in a 0 for x, that's along the y-axis, and I'm just going to draw a teeny little slashy line that's going to show a slope of 0 when x is 0. So slope of 0 are little horizontal bits, right? So I should do like more specific coordinates, but we're okay. So, but it's at x equals 0, my slopes are going to be 0. So I'm going to draw teensy little slashy lines to create my slope field or direction field. If I go over to when x is 1, let's even do when x is a half. When x is a half, then my slope is going to be a 1. So I draw this tiny little dashy line that looks like it has a slope of 1. Okay, these are not going to be perfect. Your slopes on these lines are not going to be perfect. It's just going to be an approximation. The big difference is like, okay, well, at negative a half, what would the slope be? Well, the slope, that's what dy dx is twice the x coordinate. So twice negative a half is negative 1. A slope at negative 1 looks like that. Okay, so that we can see, and I'm just going to draw a bunch of them. We can see a 0 slope versus a positive slope versus a negative slope. If I jump over to x equals positive 1, then my slope will be 2. So a slope of 2 is just steeper than a slope of 1. Is it perfect? No. Okay. Are you a computer that can figure out how exactly to draw a slope of negative 1 or negative 2 or any of that stuff? No, you're not. You're just showing a difference between, you see how the slopes are more graduated. Okay, so then on top of this, you guys have solutions through a direction field. Now, this particular DiffEq that I gave you is something that's solvable. dy equals 2x dx. If I integrate both sides, I get y is equal to x squared plus c. Can you guys see the x squared plus c's here? Like if I were to, hang on, we're back. Draw a solution curve through the point 0, 3. I would find the coordinate 0, 3, let's say it's up here, and then I would follow the flow of the field, which is a very strange thing to talk about in math class. It's a very hippie thing. If you guys have seen those Japanese sand gardens at the mall, that's what you're doing. So if you look at the shapes within here and the way that this flows this way, and this side flows this way, and what I see at the end is a parabola, right? So the solution curve through a slope field is just following the patterns of the slopes based on the DiffEq and going through an initial condition. Okay, there's step 1.